Okay, let's get started with number 4 of exam 1. So we have a function f of x defined as this piecewise function. Now I want to find the limit as x approaches 1. I want to determine if it's continuous, and I need to show all my work. Now in order to be continuous, you need to satisfy 3 conditions. First condition is that the limit exists. Okay. But not only that it exists, okay, the y value must exist. So remember, the limit just says, hey, if I'm getting close to x equals 1, I would expect the y value to be, and that's what the limit would be. But I also need to have a y value there. Otherwise, there's going to be an open dot. So I need the y value to be there. And third, that not only does the y value have to be there, not only does the limit have to exist, but the limit, what we expect the y value to be, is actually what the y value is. Okay, so those are the 3 conditions I need to satisfy. So first, let's figure out whether the limit exists. Okay, so when x equals 1, we got 1/2. Hey, so that satisfies condition 2. So, okay, we're good there. Now let's figure out the limit as x approaches 1 of this function. Alright, when x is approaching 1, it means that we're not 1. We're close to 1, but we're not 1. And f of x is represented by this right here, when x is not 1. So this can be the limit as x approaches 1 of x squared minus x over x squared minus 1. Okay, what happens when we plug in 1? Well, we're going to get 0 on top, we're going to get 0 on the bottom. Okay, 0 over 0. It's bad, but it's still good, because it means I got some stuff I can do. What we're going to do is we're going to factor the top and bottom. We're going to try to get rid of the factors that make it 0 over 0. Okay, so on the top I factor it. On the bottom, that's a difference of squares. Notice that it's the factor of x minus 1 that makes it 0 over 0. Unfortunately, those divide out, which means we're evaluating the limit of x over x plus 1, which is good because that exists. That's 1 over 2. So, let's see. We have up here, the limit of f of x exists, check. The limit of f of x equals 1/2. Does f of 1 exist? Check. F of 1 equals 1/2. And do the y value and the limit equal each other? Yes. 1/2 does equal 1/2. So that's a check. So, answer. The limit of f of x equals 1/2. And it is continuous. So yes, it's continuous. Okay, because of the 3 conditions which I just satisfied.